All right, kids. This is a continuation of the lecture on rocks, and we're going to start here today with where we left off previously, which were these features of sedimentary rock: cross beds, ripple marks, graded beds, mud cracks, and stratification is what each of those are. Moving on then, a couple of other features of sedimentary rocks are fossils and concretions. And fossils, I think, is fairly straightforward. We did look at that the other day with fossiliferous limestone. You could actually see the evidence of shells in those rocks, and so that's one of them. And then concretions. And probably some of you have seen concretions, either somebody has one that maybe they found, or maybe somebody has one that they got at a gift shop, something like that. But a concretion includes something like a geode, and I'm going to go to the camera and show you what that looks like. So this is an open geode, and you can see that it has these crystals inside that look kind of like quartz. Okay, and then there's an unbroken geode. So on this one, you can see lines where the precipitate, that's how well you can see it, but these veins along there that show evidence that it would in fact be geode. This one's not ever cut open, and if you opened it, we would expect to see something very much like this. So those geodes, and again, I would imagine that many of you have seen something like that before, and this has kind of a popped edge on it. People have them sometimes sitting out, whatever, just as a souvenir type, kind of an interesting thing. What's happened is they probably had water, and that water dissolved minerals in it, and then when the water dried out, crystals formed. And in a very simple way, some of you have seen something like that happen before. Maybe on the stove, or you've had a pan had salty water in it, and if you boil down to nothing, it's going to end up crystals on the bottom. And that's probably an oversimplification, a little bit what you have going there. Okay, so those are concretions. Now we're going to move into metamorphic rocks then. And I know I showed you the cartoon earlier, but just to remind you what metamorphic rock means, like where we're probably most familiar with it is with metamorphosis in insects, or particularly with butterflies. Complete metamorphosis goes egg, larva, pupa, adult, and anyway, so that metamorphosis occurs as a result of heat and pressure and chemical processes. And if I go too quickly through this, you can stop it and go back. But in the interest of continuing to voice over it and give you some explanation, I'm going to go on. But if you need to, you can go back. But as we advance through, make sure that while you're listening, you're getting some of this written down, so that we can kind of advance through what we need to talk about today. Okay, so what is the heat and pressure, and what do those chemicals that emit rocks and the minerals that make up rock, what happens? Well, some minerals actually change into other minerals, and then in other cases, minerals can change size or shape or arrangement. They can develop bands, which in the case of metamorphic rock, in sedimentary rock, those layers are called stratifications, which was what we talked about Friday. But in the case of metamorphic rock, those same layers are called foliations. And we'll talk about a couple of foliated metamorphic rocks, and I'll show them to you on the camera here in a little bit. But they have bands or layers. Circulation of hot magma can change the rock, and the type of change that occurs indicates the conditions under which those changes occurred. Okay, so the first one is contact metamorphism. And contact metamorphism means just what it says. It actually touches the hot liquid rock or magma. And I'm going to let you write there for a moment while I look up a picture of that. If there's a picture of what it means, contact metamorphism means. And so we're talking about the part of the rock that didn't actually melt, but it got very hot by being near melted rock. And if that's the case, it's gonna cause changes. So heat from the magma change the structure and mineral composition of the rock. And as an example, we have something called slate that comes from shale. And we'll look at those two examples while I have this up here. So let's go to that momentarily. So this is the picture from your book that shows these are layers, these layers of rock, and then we have this rock intrusion below the surface. This hot magma. It's kind of a shaded area around the perimeter of it, showing rock that is subject to what's called contact metamorphism. That's being close up to that very hot rock that it actually causes it to change. And you might remember this rock was shale, and the way you can tell it's shale is it has this kind of a dull gray color. It feels kind of slick, and the reason that it feels kind of slick, it's made of clay-sized particles. But that same rock, that shale, is subjected to contact metamorphism and become darker black, a little bit shinier, and very smooth, very hard and smooth. And that's slate. So shale can produce slate. And slate is what blackboards were made of. People used to write on chalkboards with chalk limestone, and they wrote on slate. We also talked about that slate is what pool tables, the surface of a pool table, obviously it's covered with that green or red felt, but underneath there is a very hard rock. I don't think I can make the sound because I don't have something as hard as a billiard ball, but it makes almost a ringing sound. It's very hard and dense. Okay, we're back to this. So slate comes from shale. So that's a pair of rocks, one of which is sedimentary and the other of which is metamorphic. And so these metamorphic rocks, in many ways, we're going to kind of pair them and say, this was what it was before it got changed, then it got changed and it became this metamorphic rock. Now regional metamorphism would be a large area with buried, and so the entire layer of rock is going to then be changed as a result of all that pressure of a layer of rock on top of it, or maybe several layers of rock on top of it as it got buried. Regional metamorphism. So again, that contact metamorphism is only going to affect a small portion of rock that's near enough to that igneous rock intrusion, or where the very hot magma is, that it's going to be changed by the temperature. But regional, an entire layer maybe is going to be affected by being buried and being squeezed. Okay, so classification of metamorphic rocks. Foliated. Foliated means layered. And then the ones that are in fact foliated are schist and gneiss. The one that starts G-N-E-I, or starts just G-N, you say it nice. Even though you might be tempted to pronounce the G, you don't pronounce the G. So it's just nice. And our particular sample of gneiss isn't as nice because it doesn't show those foliations quite well as some do, but I think we'll be able to see it. So The schist you can certainly see, and when you actually hold it in your hands and look at it, the layering is even more obvious. But let's take those two. So close on that. So we have this one is nice, and it's gonna be a little bit confusing because it might look a little bit like diorite, but what I want you to see are the layers that kind of fall all along there. There's white, and there's black in between, and white. Maybe here you can see it also, so a little streak of white through there. So these bands are foliations. So this one is called ice. This one is called. This one is called schist. And if you look at the edge of it, hopefully you can see that. You can kind of see layers, and it looks like it actually looks a little like mica, like biotite or muscovite. If you're those from the minerals, how they have layers like this. In fact, has mica in it. That's why it's got those shiny grains. And there are also ones that have little bits of garnet, and we looked at garnet as a mineral last chapter. Also, it's kind of got a reddish look to it, and sometimes this will have little tiny bits of garnet, little gemstone-looking thing in it, and it's called garnet mica schist. But this we're just going to refer to this as schist. But hopefully you can see the layers in it. So that's gneiss and schist. Okay. So then we have the ones that are non-foliated. And the non-foliated ones include quartzite. And we'll look at what quartzite metamorphosed from. And I'll give you just a moment to get that written down, and then I'll show you those those samples kind of comparatively. Let's take a look at those. So here, this one we passed around the other day, and the yellow is much more obvious here under the camera than it is when you're just holding it in your hand. But if you rub back and forth on this one feels really gritty. So what sedimentary rock is that if it feels really gritty? That's sandstone. Sandstone. And if you remember, sandstone or sand is made of silica. Silicon and oxygen, right? And this one then, and you can tell because it is kind of glassy looking grains. This is the metamorphosed sandstone. And so now we call it quartzite. Quartzite. Well, if you remember from last chapter with minerals, quartz is made of, it's pure silica, pure silicon and oxygen. So this is sandstone, silicon and oxygen. This is metamorphosed, and so we call it quartzite. It's not the mineral quartz, it's quartzite. So these are a pair. Sedimentary sandstone, metamorphic quartzite. Okay. Metamorphism, that heat and pressure and those chemical changes can also produce gems like rubies and emeralds. Okay, and we just about closed out actually. So just back it here. We're going to finish by look some more of these sample. I'll give you a moment to look, write those down, and then we're going to look a couple more pairs. So we already looked at schist, gneiss, and what's a notable feature of those? They have layers. It's the word for having layers in metamorphic rock. They're called, they're foliated. Foliated metamorphic rocks. Okay? And we're going to look at some more pairs of these. And let's go to that. We already looked at quartzite and sandstone, but I'll show you that again as well. All right. So we'll review a couple of we already looked at. This is quartzite. This one's quartzite. This one's sandstone. So sandstone metamorphoses into quartzite. Then these are those two that have layers. I'll turn the gneiss up on its edge so you can kind of see the layers. Okay, these layers. So this is gneiss. Excuse me. This is schist. So it looks greenish under the light, and this one is gneiss. Those are foliated metamorphic rocks. And I think we already looked at this one also. Okay, which one of these is shale and which one is slate? Well, this one is shale because it's duller and more gray. And this one is slate because it's a little shinier and more black. Sedimentary, metamorphic. Sedimentary shale, metamorphic slate. Okay. This is bituminous coal. This is bituminous coal, which is sedimentary. And this one is anthracite coal. And the way you're going to be able to tell a difference is this is more dull. Bituminous coal is dull, and anthracite coal is shinier. And I don't know if you can get a really good feel for into the camera here, but I think when you handle them, you'll be able to see an obvious difference with regard to which one is shiny. Okay, and then just a moment. I think I maybe placed one. Just give me a moment. Okay, so this, as you might remember, is chalk. And I can it's chalk because it's this smudgy, chalky powder on my finger. And this one is marble. And you may or may not have seen things that are marble. Things like sometimes headstones are made out of marble. Some people might marble countertop. But highly sought after building material type rock, and usually light colored. And it so happens this is just by chance. This is not any indicator of anything. But these can kind of have the same shape and thickness and all that. So it makes it a little easier to see, although that wouldn't always be the case. But this is sedimentary chalk. And this is metamorphic marble. And the other thing that I think you should kind of use to tell whether it's the sedimentary or the metamorphic variety is the sedimentary ones are going to be less shiny. We're turning it around as it says on the screen now. Grains of metamorphic are shinier than the sedimentary counterpart. So anthracite is shiny, bituminous coal is dull. Slate is shiny, shale is dull. Quartzite shiny, sandstone dull. Marble shiny, limestone dull. Gneiss and schist are shiny. And by shiny, I don't mean like shining like the blade of a knife. I mean shiny like glassy, just reflect light. So most of them, I guess, if we were using, which isn't really used in rock, it's used in minerals, but if we were using the term luster, they would have a glassy type luster. For the most part, Metamorphic rocks would have more of a glassy type luster. Okay. So I think there was a, oh, well, I think that's available anymore, so I guess we're not watching that, but, so guys, for Wednesday, what you need to have completed for Wednesday is, it's fairly large, so I think you'll have some time in class today to work on it, but you need to work on, in your study guide, pages 3 through 9. 3 through 9. And then I'll likely have a test moz where you'll fill those answers in, but you need to work on pages, you need to have completed for Wednesday, page 3 through 9. Here's your notes. There may be some things in there you'll have to read your book on, but start with your notes, and hopefully you have your notes highlighted so that you can find those terms in there. Okay, thanks.